Thank you. So thanks everyone for coming this morning. My name is Greg Castellucci. I am one of the senior solutions consultants for Brocade Federal, covering primarily the federal system integrator sections. So all the business related to all the SIs is what I cover. I cover all technologies. I cover the IP space, the SAN space, all the SDN space as well. And I've got my background is data centers. So covering time, spent a lot of time in the federal government working for the U.S. Army. I spent time at Fort Detrick. Thank you. Spent a number of years working at EMC Corporation, and then again, a lot of time working as a consultant for a pretty big Cisco consultant called INS, International Network Services, and then spent time at General Dynamics. So I kind of spread the spectrum around of some of the background I have in this space and saw a lot of this stuff deployed and operational, both in the engineering components of it and then in the O&M of it. So got a lot of background in this space. But what I wanted to talk to you guys about today is Ethernet fabrics. This is a new technology. Well, it's relatively new. It's been around for a number of years. But what I wanted to first splash on the screen here is something I've been up against for quite a while. One of the things that I think we need to get our hands around is what the new changes are that's happening in the data center space. The revolution in the data center has been coming along for quite a while. And what I'm up against, what we seem to be up against in this new IP transition is trying to get away from the way we used to do things. I don't know how many CCIEs are in the crowd right now, but I spent a lot of time in that space doing a lot of Cisco work. What we have found, though, is that influence has been around, is still in this space where we've done it this way for a long time. We've got this type of architecture, and I'll show you what the architectures look like between the old and the new. And it's been a very hard thing to try to move the mindset from how we used to do things in these data centers to where we are now. So again, this little graphic's been on the wall at Brocade. Thought it'd be interesting to show you. Again, if I had to visualize what I'm up against with this new IP transition in the federal space, that's kind of what I'm up against. Everyone's too busy trying to maintain what they've got and keep doing things the way that they've always been doing them. There's no time to integrate into the new. And now it's time to do that. Spinning our wheels, our square wheels around, maintaining these data centers and not letting this innovation in it's critical. With SDN coming into this picture, maintaining these data centers and these architectures on the old platforms where we used to do things has got to change. A little bit about the agenda today. Again, how we're doing networking across the industry is changing. Brocade coined this as the new IP. This is SDN technology. This is Trill fabrics now in the data center. This is that merging of the storage area network with the top of rack, with all the server access layers, right? And then the platforms for SDN underlay. Phil talked about this a little bit. I'm going to go into it a little deeper, but then again, if you want to get really deep, we've got some of these demos actually running in the Tech Pavilion, so you can see these things operational. Then I'm going to talk about this underlay. Again, Phil hinted at this as well. What we need to do, and what you can start to do now, to get ready for deployment of SDN technology, which is relatively new. You can set those foundations today. And there are benefits to doing that now, where you can actually integrate into that virtual infrastructure with Ethernet fabrics to be ready then for SDN technology and the controllers that are coming into the space. And I'll talk to you guys a little bit about how SDN can now orchestrate these Ethernet fabrics, okay? Phil's correct. This thing jumps pretty fast. So a little bit about what the new layers look like in the data center space in this cloud model. The bottom layer. One of the things that I've been told from VMware is that you don't need to worry about this underlay. The virtualization will take care of that. You don't need it can be anything that's in that underlay. That's actually becoming a little bit different now. Because what we're seeing with the ability of the servers and the data that virtual layer now needs to read off the underlay to then auto-correct itself, there are some smarts you're going to need in this underlay. And we'll talk about where we are, Brocade are in this space. The services on top of that, this is that virtualization layer, right? Phil talked about this as well, NFV, Network Functions Virtualization. Taking those hardware-based appliances and functions, virtualizing those, and putting them in a hypervisor, and letting those live down the server access layer for multi-tenancy and really large capabilities as far as scalability. And then the control. Now, so Open Daylight, Brocade is a real champion of this. We've been involved in this from the beginning. Almost at the same time that we developed the Ethernet fabric technology, we were involved in a lot of the SDN technologies and the standardizations coming around. So we baked a lot of the SDN technology ability into the Ethernet fabrics already. So you're already future-proof for this. And then as you move up the stack, you're going to take a look at we're going to take a look at orchestration. There's two big contenders in this space. There's OpenStack, which is the standards body that a group of consortium in industry got together and started this OpenStack capability where you're able to now orchestrate the entire data center from the operating systems to the storage provisioning to now the networks and even now security, right? Orchestration from that top layer. And then providing the customer with a portal to then set and configure his own environment. That's the orchestration layer. VMware vRealize does a lot of the same thing. I don't know if you heard about that as well, but they're in this space too. And we work with both of these technologies, so I'll talk a little bit about that. So the importance of this intelligent underlay. What we see now is, and I'll get into another diagram of what this looks like, but if you talk about the SDN capabilities, the open flow, where you're able to set and control your forwarding of your packets using a centralized controller and create these flows, you got to push those rules out to something. And that needs to be able to understand that type of protocol, the open flow protocol. These underlays do that. The orchestration as well. The APIs needed in order to communicate to these controllers. Those underlays need to have this intelligence too. And then, of course, the VMware, right? Big in our space, big partner of Brocade's. Same kind of thing. This underlay needs to have the intelligence in order to be able to communicate to the VMware tools and the VMware hypervisors, right? To be able to enable a lot of the virtualization down the server layer. And then we talk about convergence as well. The underlay, Ethernet fabrics, you're talking about a layer that can handle all the communication from that server infrastructure to any storage that you need to direct that traffic to, be it fiber channel, iSCSI, NAS, fiber channel over Ethernet as well. These fabrics, Ethernet fabrics, are going to be able to handle that, need to handle not only the IP data traffic and the SDN, but how do I get to my storage, right? This is where the underlays become even more important, okay? And then application awareness. What's driving a lot of this change, and has been over many, many years, it's been increasing, right, is the applications. The application teams, the system administrators that run these apps need to take more control of that server access layer. And how are they going to do that? Through that underlay. We've got to provide them the APIs and that infrastructure to get down to the application layer and take control about how do I move my app? How do I scale my app around? How do I move an app from one server to another during times of peak use? Right? This is another capability that you're going to need in this, what we call underlay. So again, just capitalizing on what I just said a minute ago, we're looking at these Ethernet fabrics, this layer, what we call the virtual access layer, resiliency, efficiency, simplicity. Some key terms you're going to hear again and again, but I think now, more than ever, this is something we need to really look at. Being able to be resilient, avoid the risk, be able to build some protections into this thing, some automated failover inside the Ethernet fabric. Efficiency. How do we avoid the problem of over-provisioning? So in the years I spent at General Dynamics, one of the biggest issues was how do we plan for this growth factor that may be in these RFPs? Sometimes it's 20%, 25%. Sometimes they don't know. Sometimes the government agency says, you guys figure that out. Well, that could be a problem when comes time to put together your cost model, because then you got to build in 25% extra. You build your solution, bolt on 25% more. Now you may have some risk there and losing the bid. So how do you get around that? Well, Ethernet fabrics provide a dynamic scalability capability. Right? How you can turn these links on automatically. You can bring up ports on demand. Okay, that's another very important requirement now in these data centers. Again, simplicity. the complexity that's needed now, it's unaffordable. Continuing to staff with subject matter experts all over to maintain these complex layer 2, layer 3, infrastructures in the data center, and having you constantly manipulate VLAN, QoS, all these types of security, these types of manipulations now that has to happen on every single port on 3 different tiers in that data center. It's driving a lot of this change right now. And I'll show you some slides on that. But the way to solve this, again, Ethernet fabric technology, the underlay technologies now have that smarts built in. Phil hinted at a lot of that, but I'm going to deep dive on some of it. Here's the same slide Phil had earlier. There are different ways to build an underlay. You can build a campus-style underlay that can handle SDN-type rules and changes and flows from OpenFlow and OpenStack with stackables. The issue here is that it's great for campus, but in the data center, that's where a lot of this needs to change. So this is still like spanning tree-based technology now in the campus, but it's stackable. So you're still going to have some of these complications of having a network engineer continually monitor and upgrade and refresh and continue to make change modifications manually in a lot of these stackables architectures, right? But they're incredibly scalable. Fabric switches. Again, what I'm talking about today and what Phil hinted at today, the simplicity, the elasticity now in that data center that is now manageable by federal agencies to be able to have a vendor be able to support this type of intelligence now. Ethernet fabrics, again, build that technology. Fabrics in general, not only Ethernet, but storage area, fiber channel networks, fiber channel fabrics, right? This is where a lot of this technology came from. Is there any SAN engineers in the audience right now? Do you know anything with fiber channel? If you look back at how fiber channel has started and become a main capability for high performance computing now in the data center, people thought fiber channel was going to go away years ago. The reason why it has not is several reasons. A very simple infrastructure to maintain. If you bolt on fiber channel switches together, the ISLs automatically bring up aggregation groups, and the switches learn about each other as you build out this SAN. The same type of technology now is in these Ethernet fabrics. You can scale these out really simply. And the profiles, what's what we call profiles from zoning and SAN, profiles and Ethernet fabrics, copy from one switch to the other. So it's amazingly scalable. No touch configuration from switch to switch. And Phil also talked about the white box platforms. Excellent for gigantic organizations who have an army of electronics engineers who can actually manipulate and build boards or buy the pieces and put them together. Kind of not a supportable model in federal. The idea of if a switch breaks, you don't have to buy maintenance on it. You just pull one off the shelf and pop it in place. There's still some support models that need to get worked around in federal. There needs to be someone needs to get called when a box has a problem, right? And when you talk about the white box technologies, like I said, the Googles, the Yahoos, the Microsoft Azures, these rack space, right? These huge providers have that ability to just have teams of these engineers build these boxes. Ethernet fabric, and what I'll talk about, the Brocade product, VCS, that's where the inexpensive Ethernet fabrics that provide you the same types of quality and capabilities, that's where we're going to see a lot of this move to. So let's talk about this change from the hierarchical network or hierarchical construct into the Ethernet fabric, right? So what do we have right now in data centers? That we're looking at pretty much a 3-tiered model, right? The top of rack, the aggregation, maybe an end of row, and then a core. So a 3-tiered model. And then all the servers at the bottom have to go up those tiers to even talk to the server next door. Now, this is incredibly restrictive when we talk about virtualization down at the server level, because all those servers need to traverse those hops to get to that server right next to it, where the east-west traffic has been escalating over the years because of this sprawl of VM virtual machines across the server layer. No longer sustainable to keep maintaining this model. You have to have an army of network engineers out there configuring VLANs on 2 or 3 tiers. Not only that, but then you have to worry about what's my latency between my web server and my database. My front-end web server and portal in the database, right? There's a latency problem there too. So this, again, very inefficient link utilization. If you notice the dotted lines there, that's the spanning tree implementations, right? One link is always down, blocked, right? Spanning tree loops are, and if you're a network engineer, one of the things that I think you spend most of your time on is either preventing what could be a spanning tree loop or dealing with a spanning tree loop when it happens in a data center. I think about 70 to 80% of network engineers spend their time troubleshooting those kinds of problems. Well, there's a better way to do that. Let's take spanning tree out of the picture, right? The fabric architecture. What has happened now, or what has been the migration in technology and industry is this was realized as an issue. The virtualization that has grown exponentially in the data center space, and the problems with spanning tree, blocking a lot of the capabilities of the virtual machines to talk to one another, and that east-west communication becoming critical has driven the standards bodies to develop new types of protocols. Trill protocol is one of those. And that, in essence, is what a lot of the Ethernet fabric technologies are built on, the Trill technology. And when you talk about that, we're looking at creating all links now active. You put these Ethernet fabrics together, you hook them together, all of a sudden they recognize each other, and you can start transmitting data. You don't need to get on every single box in VLAN and configure each one for every server that you put in that Ethernet fabric, or between the boxes, right? You don't need to manually configure link aggregation groups. They form by themselves. And are managed as one switch. So you can create an Ethernet fabric of, I think we're up to about 35 or more switches now in Ethernet fabric, Brocade, but that's only theoretical. As we start to create more and more larger scale models of Ethernet fabric, this is going to continue to grow, right? So again, VMware as well, you're going to see a lot of virtual machines now needing the smarts of this underlay to know where do I vMotion to, or if I vMotion somewhere, am I going to be able to transmit? Now, the Ethernet fabrics, Brocade VCS, has got that intelligence built in. So you don't need to worry about if you've got those VLANs over here on this hypervisor. It'll be there, and I'll show you how that works. So let's take a look at the VCS multipathing, right? Brocade's Ethernet fabric is called VCS, Virtual Cluster Switching. If you take a look at the construct on the left, let's break this down, okay? So Ethernet fabrics are built, VCS is built with, at layer 1, we've got an ability to auto load balance between every switch as they connect, as you're bringing these up. It's called ISL technology. If you're familiar with fiber channel networks, you'll know that that's where that comes from. The ability to interconnect these switches, and they automatically load balance between each other. That's a layer 1 technology. Don't need to worry about that, built into the hardware. So the Trill technology brought this protocol called ECMP, Equal Cost Multipathing. So as you build these Ethernet fabrics, you have the layer 1 load balancing happening between each switch. Now you have the Trill protocol balancing across the fabric, right? ECMP, okay, that's a standard protocol adopted in the Brocade VCS. The lady who invented spanning tree knew or saw this issue, Radia Perlman. Saw that we've got to find a better protocol. And the IETF, she worked with the IETF standards body to create this Trill protocol to get around these data center loops that are causing such trouble with the virtualization migration. And so as we build out layer 2, the equal cost multipathing, we've got to talk about, okay, as I build out a huge Ethernet fabric, how do I speak layer 3 to those switches above me? Well, VCS has got an ability called, has a layer 3 capability to be able to distribute layer 3 default gateway at the top layers to the switches above. And they don't need to be Ethernet fabric. They speak standard protocols, so link aggregation, LACP, LLDP, all these types of standard technologies, this Ethernet fabric will integrate to that. So to a spanning tree environment or to core switches that may be from another vendor, if you take a Brocade VCS Ethernet fabric and connect those up, it looks like one switch. So the entire Ethernet fabric looks like a single switch. And then we can actually, those switches will look at this Ethernet fabric, and we, as multiple default gateways, they won't know that it's multiple switches. So we have an ability to be able to do that with default gateway at layer 3. And there's more layer 3 ability built into the Ethernet fabrics as well. And if you got questions about that, I'll be happy to answer those. We can talk about it. So let's talk about a little bit more detail. Ethernet fabrics, what is it that they bring to the table with server technology, with virtualization? How do they enable me in my virtual environment to take advantage of these capabilities? Well, in the Trill protocol, what is defined is that these switches are called route bridges, RBs. Okay? So each switch in an Ethernet fabric is a route bridge. So you have a number of these, and they're interconnected. And what happens is it'll recognize via MAC address, I've got a server coming into my Ethernet fabric. And manually, you've got to do this at least once. You have to set up what's called the profile of that server, that virtual machine. Once you set up that first instantiation of that virtual machine or that hard metal server, it'll propagate that port profile to every switch in the Ethernet fabric. So the entire switch is aware that this MAC address exists in my fabric. And how is that useful? Well, if you take a look at hypervisor technology and virtual machines, one of the things you need to do and is now being automated is at peak times, I may need to move this virtual machine from one server, physical, to another server. And what this allows you to do is take that virtual machine, move it over to any other hardware machine or virtual machine or hypervisor. It's agnostic as well. It doesn't matter if VMware, could be Hyper-V, could be Zen desktop, Zen server. It doesn't matter. As long as it's got a MAC address, it can be captured in a port profile and moved around. And this is really important for the system administrators. They don't need to call the network engineer, okay, to keep hassling them to say, I got a vMotion issue. Can you make sure my VLANs are over on this server at the end of the row? That is a huge problem now. Resolve with this type of technology. And the good news is our partnership with VMware and the other hypervisor providers in this space, you can manage this entire thing from vCenter. So if you want to be able to import all virtual machines from vCenter into your Ethernet fabric, it'll auto-populate that entire Ethernet fabric with all those virtual machines. So you don't need to manually do that anymore, okay? So that's part that, again, this is the integration we're talking, the intelligent underlay that Phil was talking about earlier. So here's what I was just talking about. You can log into any one of these R bridges. The master switch is probably the best. So again, deep diving into some of how this works. We can talk about that later. But from the master R bridge, what you do is you can actually log in to the vCenter server and do an import command. Populates all of those virtual machine port profiles into the fabric. So let's talk about multi-tenancy. This is another question that comes up. Greg, this is great, but if I got multiple tenants using the same Ethernet fabric, we're going to have some contention for resources. Or they don't want their data mixing into the data, or they need their own VLANs, and it can't change from this VLAN, these VLAN numbers to new VLAN IDs. How will we handle that? Well, Brocade brought in to this technology an idea of virtual fabrics. You can now, in the same Ethernet fabric, with the VFID, create virtual fabrics inside. So every tenant is now segmented within that virtual fabric. So you can take, let's say you've got a number of virtual machines, different tenants, different colors, and tenant red says, I need to be able to take advantage of Ethernet fabrics and spread my environment across several route bridges in the Ethernet fabric. How can you do that? Well, we're able to do that now because we have this VFID ability. So you can take multiple tenants and spread them around across the Ethernet fabric build-out and be able to give them their own domains, right? Tenant 1, 2, 3, as many as you. I don't think there's a limit yet. So. Again, this is a technology I think that is that intelligence, right, into the Ethernet fabric. So where do we see this now? So this technology is all across the Brocade VDX space. The 6940s, 6740s, you see some of this out there in a Tech Pavilion as of NOS 4.1 and on. Again, you can use this as a service fabric. Again, VLAN IDs, you can set these VF IDs up to be able to do and service any type of requirement in your data center. Transport fabric, VF by port, by VLAN, or per MAC address, right? And what are the use cases here? So some of the use cases for virtual fabric. Enterprise private cloud. Again, the idea of being able to do multi-tenancy down in that Ethernet fabric, right? Virtual fabric per department business, right? Doesn't matter. Service providers in public cloud. We're seeing a lot of, if you look at Amazon Web Services, right, and you look at any rack space, the tenants that are being moved into these clouds now need their own virtual private space to be able to do what they need to do with their apps. VFs and being able to segment them now and keep them in their own domain. They don't know there's multiple tenants sharing that same space, right? This is virtual, but it looks like their own space. So one of the things I'm also asked about is, let's say I have an existing data center. How do I go from an existing data center that may have a lot of legacy equipment? How do I migrate that or upgrade that into a new Ethernet fabric or an underlay environment getting ready for SDN? Well, Brocade knew this problem was happening. We saw this years ago. And what you see here is there's multiple ways to scale an Ethernet fabric into an existing architecture. As I said a little bit earlier, we've got an ability to integrate into an existing spanning tree architecture because our Ethernet fabric just looks like a spanning tree bridge. It just passes those packets right through. So it's not going to become a bottleneck or a problem or cause a forklift of any equipment in the infrastructure. You can build out, and this is how I've usually seen these deployed. You build a pilot architecture with maybe a rack of Ethernet fabric, right, and start moving tenants into that as you go, and it won't disturb the existing environments, right? So basically, this is the high points of what I'm trying to show you right here. And as you grow and as you scale Ethernet fabric, you can continue to move tenants into that Ethernet fabric as you go. Again, we saw this issue a long time ago. No rip replace, no forklift required, okay? So I talked about the idea of Ethernet fabrics being the ideal platform also for storage. Now, our partnerships with EMC, NetApp, all the network addressable storage arrays, we have built-in prioritizations now into this Ethernet fabric. So you can define where these controllers are as far as in the NAS example, you can define an IP address of that the controller, inside the Ethernet fabric, so that when the storage is requested from the servers, I need to get to my storage, that is assigned a priority. So that will be able to take precedence over maybe a normal user access down at that virtualization layer in the Ethernet fabric. So again, this is built into the Ethernet fabric. Again, multi-IO, multi-storage. The whole idea of Ethernet fabric is it is the collection of all the transport that you need to do in that data center. Okay? All right. Here we go. So, one of the other things we've been talking about, and the idea that has been conveyed so far in new IP is the ability to, enable SDN technologies, network functions virtualization, the SDN controllers, and then the orchestrations as well of those environments, of the underlay, of the overlay. Well, Brocade, again, we're very involved with these organizations from the very beginning. So we have that technology, the APIs, the integration already into these controllers, OpenStack as well, right? We've got the APIs are already in OpenStack to communicate directly to the virtual fabric, the Ethernet fabric environments. So you can take advantage of the orchestration to, set your network configuration, be able to push out policy to the Brocade devices, Ethernet fabric devices, security stuff as well. So this type of integration is already built into our devices. Now, on the right-hand side, it's not just Ethernet Fabric we're doing this on. The Brocade Viata V router, which you'll probably learn about today, Ethernet Fabrics, our load balancer devices, and the MLX product line, the Layer 2, Layer 3 product lines, and the Fiber Channel SAN as well. So we've already integrated a lot of this technology into these standard orchestration SDN controllers, open flow controllers. We're in this space very heavily. You know, we're already supported. So one of the things that is asked of me is, you know, one of the things that I like to say is, if you take a look at what Red Hat did for Linux, Brocade is doing for this SDN community. So again, you're going to learn a little bit about this as you go along today. But again, like I said, we are in this space, this SDN, this new IP space. And I think one of the differentiators for us is we knew this was happening. We've had this product for 5 years. It's not going anywhere. The Ethernet Fabric, the VCS products, VDXs, is not something we need to say, oh, we made a mistake, we got to back out and do something different. We've been at this for 5 years. We know this space. We know fabrics, right? And we're continuing along this track. And it's been extremely successful. And again, as we look at this Ethernet Fabric technology as an underlay, it turns out it is the perfect platform for being able to do SDN orchestration and to push out flows and control. All right, so again, very powerful platforms. And I think Phil hinted at this too. The ability to do API integration from the SDN controllers into Ethernet Fabrics already built in to a lot of these products, okay? So being able to do, so these products come with an ability to do a REST API. So you can inject Python and other scripting and programming languages and actually do programmatic control into this Ethernet Fabric, okay? So again, if there's anything to take away here, I got some summary slide. Oh, didn't make it to the final. Basically, the points I wanted to make here are the underlay is now an important part of the new data center. And what Brocade have in this space with the Ethernet Fabric is a key differentiator to be able to, for the data centers of today and the data centers going forward. Brocade VCS Ethernet Fabrics transform that data center. The Ethernet Fabric, the multi-IO ability, be able to do connectivity to all different types of storage. The idea that you can now orchestrate and control these Ethernet Fabrics to be able to be the single source of configuration for your entire virtual server layers. Again, we've been doing this for a number of years. Key technology in the data center today. So thank you very much for your time. I will be here to answer any questions. I just got the hook that looks like my time is up. But again, I'll be here. The Tech Pavilion next door has got a lot of these demos set up to show you things that I just talked about right now. Yes?
Are these presentations available on the website?
Yes, they will be. Everyone today will be able to have access to these presentations. Yep. Any questions, right, for what I just showed you with Ethernet Fabric? Again, Tech Pavilion's here all day. Enjoy talking to those folks. We've done this, and at the Tech Pavilion, all the systems in that Tech Pavilion have as their core the Ethernet Fabric architecture. So pretty cool to see that actually running. Thank you very much.